So we're going to start talking about some trig identities. The basic 8 is what we're going to start with. And so just a little bit about identities. Right here in the little box it says an identity is an equation that is true for all values for which the variables are defined. Okay. So when it comes to our trig functions, we know that sine and cosine are defined, their domain is all real numbers, so there's not a place where those aren't. But tangent had pi over 2 and the odd multiples of pi over 2 where it wasn't defined. So any of the identities involving tangent would not be true at those odd multiples of pi over 2 because it's not defined. But one example that they give you that you might have seen before is that from algebra, a squared minus b squared equaled a plus b times a minus b. We had some others, but that's just an example of one of the identities. So in trig, we have a few different ones, and so we'll be looking at what those might be. All right, so we're going to go back to the unit circle. I know, yay, you're excited. All right, so on the unit circle, and where r equals 1, so from the center to the edge of the circle is 1 unit long. And then we have some x and y at a point P on the circle that's also on our radius. Okay, it's the end point of the radius for that circle. Okay, so we know that sine theta in this instance was y over r. Well, in all instances is y over r, and so in this instance it's y over 1, or simply y. Okay, likewise, cosine theta was x over r, so in this case it would be x. Then tangent was y over x. And then we had our reciprocal functions. So that would be 1 over y, 1 over x, and x over y. Okay. So that's just a reminder. This is our 6 trig ratios. All right. Also, we have the equation of the circle. Now, hopefully you remember from algebra 2 the equation of the circle, but if not, it was given as x minus h squared plus y minus k squared equals r squared. Okay, where h and k was the center of your circle. Okay, so for this particular circle, the center is 0, so we're just going to have x squared and y squared. Let me back that up. The center is 0, 0, the origin. Okay, so we know that's just going to be x squared plus y squared. And then since r is 1, r squared will also be 1. So there's the equation of that circle. For our ratios, we can come up with some reciprocal identities. So, since cosecant theta was the reciprocal for sine, instead of saying cosecant theta equals 1 over y, we can simply say cosecant theta equals 1 over sine theta. Okay. And since secant theta is the reciprocal of cosine, it's equal to 1 over cosine theta. Okay. And cotangent theta, likewise, being the reciprocal of tangent, would be 1 over tangent theta. All right. And because tangent theta is y over x, and we know that sine is y, sine theta equals y, and cosine theta equals x, we can simply say that tangent theta is equal to sine theta divided by cosine theta. And then because cotangent is the reciprocal of that, we can say that cotangent theta is equal to cosine theta over sine theta. Okay. So that's using our ratios and reciprocal identities based on the relationships we'd already seen. Okay, so as we continue on, single term identities can be squared. okay, to form new identities. So taking those last reciprocal and ratio identities, if we square them, then we create new identities that would also be true. Okay, so if we square tangent theta, we'd also square sine theta over cosine theta, and we would get tan squared theta, and then sine squared theta, and cosine over cosine squared theta. Okay, so we could, if we came across tangent squared theta, it would be equal to sine squared theta over cosine squared theta. These would be interchangeable. Okay, cosecant theta, if we square, we would also square 1 over sine theta, and we'd get that cosecant squared theta equals 1 over sine squared theta. Okay, and you could do that with any of the other identities that we just wrote down on the other page. This is just two examples of that. All right, so now let's take on the idea of the circle, okay, because this was based on the ratios. We had simple ones, and now we've squared them. So what about that circle thing we wrote down? Okay, well, Pythagorean identities and the formula for the circle that comes from our understanding of Pythagorean theorem, right? A squared plus b squared equals c squared, and you had the x squared plus y squared equals r squared. Okay, our Pythagorean identities will start with the circle, which was x squared plus y squared equals 1, and then we'll replace, because we know that cosine was equal to x, so x squared would be cosine squared. Okay, and since sine was equal to y squared would be equal to sine squared. Okay, which would then also be equivalent to, right, because addition is commutative, we could also say that sine squared plus cosine squared, oops, I forgot my theta, is equal to 1. Okay. Now, with a little bit of manipulation, we can create some other identities. Okay, so going along this line, we could divide everything here by cosine squared theta. Okay, because we're allowed to do that. We can, as long as we divide everything by the same thing, right? Okay, which cosine squared theta divided by cosine squared theta is 1. And then sine squared over cosine, right, that's tangent, so tan squared theta. And 1 over cosine was secant. Okay, so we've created another identity here. So this would be one of our identities that we could use. This is also an identity we can use. And here's another. Okay, and then the ones we listed on the front page. All right, so similarly, if we take this one and divide everything by sine squared, well, sine squared divided by sine squared is 1. Cosine over sine is cotangent, so cotangent squared theta. And 1 over sine squared theta would be cosecant squared theta. Okay. So just using those few pieces, we have created, oh, I shouldn't say created, but we have defined some identities that will help us in solving and simplifying trig equations. If our note here says these identities can be solved for any term to form new identities. Okay, so we've got some more that will come off of just these this handful. So one of the things we can do is we can take and just solve for cosine, right? So if we isolate cosine, right, we would be subtracting sine squared theta, which means we would get cosine squared theta is equal to 1 minus sine squared theta. Similarly, if we chose to solve for solve for sine, right? If we had done that, then we would have subtracted cosine from each side, and we would have sine squared theta equals 1 minus cosine squared theta. Okay. So those are other identities that we can use. Okay. Then 1 plus tangent squared theta, if we were to solve it for the 1, right? We would subtract the tangent squared theta. So 1 would be equal to secant squared theta minus tangent squared theta. We could also solve for tangent squared theta, which we would be subtracting the 1. And we would get tan squared theta equals secant squared theta minus 1. Okay, and just the same for the cotangent, 1 plus cotangent squared theta. We could rewrite that as 1 equals cosecant squared theta minus cotangent squared theta. Or we could say cotangent squared theta is equal to cosecant squared theta minus 1. Okay. So just once we had the basic identities, we started manipulating them to create others. Okay.